All right, so what we're going to be doing today is we're going to be taking a look at Chapter 1. And the main thing that I want to focus on in Chapter 1 is using frequency tables and graphs. So this is going to be one of our first sort of really statistical things that we kind of take a look at that is going to be used throughout this entire semester. So last time we learned about summation, we learned about order of operations. You're going to see those two concepts going forward for the remainder of this course. Same thing with using tables and graphs, especially graphs. We're going to be doing that as well throughout the rest of this course. So today is when you are going to learn about those tables and graphs. So first we're going to briefly go over the concepts of descriptive versus inferential statistics, because what we're going to be doing in the first part of the class is mostly descriptive statistics, and then later we're going to apply those to do some inferential statistics. And then we're going to talk about frequency distributions and how they're represented in frequency tables and also histograms or frequency graphs. And then I'll mention homework assignment number 2, and the remainder of their class will be an open practice time for those of you who've been trying especially the order of operations. Just in case it didn't work out, we'll have the rest of the class devoted to that. All right, so just to remind you, currently we're in this phase of learning about statistics. So learning about reading tables and graphs, this is going to be the basic fundamental skills that we're going to practice over and over and over again. All with the promise that eventually we're going to be able to do the really cool stuff that statistics enables a psychologist to do, like make decisions about whether a treatment's effective, make decisions about whether an intervention actually produces the desired result. However, be sure that you are putting in all the work, all the practice, do the pre-tests, do the post-test, try the in-class practice. Just make sure that even if these skills may seem simple, at first, remember that we don't just want you to understand these skills. Right now we're working at getting them to be automatic. So you really want to put in the practice, even if you find it a little straightforward, until it really is just bang, bang, bang. You do it automatically as soon as you see it. All right, so let's first start with the difference between descriptive and inferential statistics. So descriptive statistics, the statistics we're going to focus on over the next few weeks, this is used to organize, summarize, and basically make data simpler to understand. So in any data set, you might have 20 numbers, 30 numbers, 50 numbers, 100 numbers. You might have 10,000 scores. If you do a large survey, you might have 100,000 scores. So numbers are something that our human mind is very bad at grasping. It's very bad at understanding large amounts of numbers. So descriptive statistics is how we take those large amount of numbers and simplify them down to a meaningful, smaller, more understandable unit. So say, for example, as you are looking at the effects of sports, you're a sports psychologist, and you're looking at the effects of sports on life achievement, right? So you want to know, does competing in sports actually help individuals later on in their life, in their job, in their love life, in their workplace? Does it increase the quality of life? And what you might do is you might start taking a look at people who play, for example, basketball, and you might ask them questions about their quality of life to measure that, that relationship. So let's say that you talk to this kid over here who's been playing basketball for a couple of years, and let's say that you measure this college student over there, and you measure that high school student over there, and you measure that guy sitting back there who doesn't look to be having too much of a good time right now on the sidelines. But let's say that you ask all of them about how long have you been playing basketball and what is your quality of life. Now, this is only 4 scores. Typically, you would do this for hundreds of scores. And when you end up with those hundreds of scores, it's very difficult to see a relationship if you're just looking at the raw numbers. So descriptive statistics are a way of taking all of those scores and simplifying them often down to one number. So how many years have you been playing basketball? You can take 100 scores and simplify it down to the average number of years. What's your quality of life? You can take those 100 scores and simplify them down to the average or the median score. We're going to see what that is in the coming weeks. So one score our minds can understand. So that's what descriptive statistics is going to be about, taking those very numerous scores and reducing them to a number that we can, one or two numbers that we can understand. Inferential statistics, on the other hand, is when you use statistics to make generalizations about a population. So inferential statistics is really where the power of statistics comes out in psychology. It's actually what makes psychology possible, because what you can do is, in psychology, we only ever study samples. And what we do after we study those samples is we make generalizations about the population. So if we studied a sample of basketball players and we found out that their quality of life is higher than people that don't participate in sports, without inferential statistics, that's where the story ends. We could say that for these 4 people, they played more basketball than your average individual, and those 4 people, they actually have a higher quality of life. Which means that if somebody came to us, right, as a psychologist, somebody came to us and said, you know what, I have a low quality of life, or I want to ensure that my child has a high quality of life. Can you suggest anything that I might be able to do to improve my quality of life? And you would sit there and say, well, I know what improves these 4 people's quality of life, but for you, I don't know. Could be anything. That's what psychology would be like without inferential statistics. It would be useless. With inferential statistics, though, we can take that sample that we looked at, and we can intelligently and systematically and without introducing human bias say, all right, we found that basketball improves the quality of life for this sample, and with inferential statistics, I can now generalize that to the entire population. So that when that client comes in and says, you know what, I want to improve my quality of life, or I want to improve my daughter's quality of life, what can I do? You can say, oh, I studied this sample, and based on that sample, here is what I can tell you you should do. This is my generalization about the population. So inferential statistics is going to come later. First, we are going to focus on descriptive statistics. And the first descriptive statistic we're going to look at is how to handle frequency distributions. All right, so frequency distribution. Here's an example of a frequency distribution. And what a frequency distribution is an ordered listing of the number of individuals that have a particular score for a particular variable. So it's an organized, ordered listing of how many individuals in your sample ended up with a particular score. So this is an example of a graph of a frequency distribution, and this is hypothetical data of scores on a quiz. So in this quiz, you could score anywhere from 0 to 100%. So this is everybody. So this is the category of scores from 0 to 9. 10 to 19, 20 to 29, 30 to 39, 40 to 49, 50 to 59, all the way up to 90 to 100. So on the x-axis here, we have the possible scores. I'm going to emphasize that later on. These are the possible scores. And then each of those bars represents the frequency with which those scores occurred. What that means is that each of those bars represents people that attain those scores. So one way that I like to think about this is you can think of this as a big apartment building, and a single individual lives on each floor. So looking at this frequency graph of this distribution, I can tell that there are 2 people that achieved the score between 50 to 59. 2 people live in that apartment building. Right next to them, there are 5 people that achieved a score of 60 to 69. Right next to them, there are 4 individuals that achieved the score of 70 to 79. 5 other people achieved the score of 80 to 89. And then we have one person living all alone, and they achieved the score of 90 to 100. So a frequency distribution allows us to organize our scores by how many individuals achieved a particular score, or in this case, a range of scores. And notice that it also very effectively communicates the fact that nobody is living in these apartments over here, so nobody scored anywhere between 0 to 9 up to 40 to 49. So that's the idea of a frequency distribution. It's scores stacked on top of scores. And these frequency distributions, they can be structured or they can be shown as either a table or a graph. So what we just saw was an example of a graph of a frequency distribution. We're going to take a look at frequency tables first, however, because they are a little bit easier to construct, a little bit easier to work with for certain cases. All right. Any questions? So far, so good? All right. Frequency tables. So considering the following set of 20 scores on a 10-point quiz, so there's a little bit of statistic notation for you. If you see an N, capital N or small n, that refers to the number of scores. So if you see n equals 20 scores, what that means is that this set of scores has 20 different scores. So we got 20 different scores on a 10-point quiz. There they are. And right now, the way that they are, very, very difficult to deal with. So if I wanted to know how many people scored 8 out of 10 or better, it's going to take me a while to figure that out. If I wanted to know, oh, students that scored 5 or below need tutoring, how many students need tutoring? Once again, difficult to do. However, you can construct a frequency table of those scores, and that's going to help out to understand. That's going to be our descriptive statistic technique that's going to make sense of those scores. All right, so frequency tables typically have 2 columns. They got X, they got F. X is the score column, F is the frequency column. So once again, F, read that as frequency, X, read that as the scores. And unfortunately, frequency tables are actually lying a little bit, because that symbol for the scores, that X, it doesn't stand for the actual scores, it stands for the possible scores. So whenever you're dealing with a frequency table and you see that X, try to get into the habit of saying possible scores, because as we're going to see, that can lead to troubles later on. So the first column is the possible scores, the second column is the frequency with which those scores occurred. So on this 10-point quiz, one possible score is a 10. Maybe somebody got it, maybe nobody got it, but it's a possible score, it goes into that column. Another possible score is a 9. You can get 9 out of 10. You can get 8 out of 10. You can get 7 out of 10, 6 out of 10, all the way down to 0 out of 10 if you got every single question wrong. So those are all the possible scores. So again, do not read this as the scores like you would normally. In a frequency table, read that as the possible scores. All right, so let's zoom in on our scores a little bit so we can see how we go about constructing this frequency table. So what you would do when you construct a frequency table is you basically, either you or a statistical package, would scan the scores and count up how many of each of these possible scores actually occurred. So for a possible score of 0, you would go through these 20 scores and you would say, nope, nobody scored a 0. So the frequency column gets a 0. 0 people got a score of 0. You would do the same thing for a score of 1, and you would find out that 0 people got a score of 1. You would do the same thing for a score of 2, and this time you would see that, well, we got one score of 2 right there. We got a second 2 right there. 2 people scored 2 out of 10. So the frequency for that possible score is 2. Do the same thing for 3. Scan it. We got 1 3 right there. We got a second 3 right there. The frequency with which a score of 3 out of 10 occurred is 2 as well. And you continue this for every single possible score. So for 4s, we got 1 4, we got 2 4s. The frequency with which 4 out of 10 occurred is 2 as well. For 5s, we got 1 5, we got 2 5s. So once again, the frequency for a score of 5 is 2. For 6s, we just have the one person that scored 6 out of 10. So that frequency is a 1. For 7s, we have 1, 2, 3, 4 individuals got a score of 7. So the frequency of 7 out of 10 is a 4. And then so on and so forth. For 8s, we got 1, 2, 3 8s in our set of 20 scores. And then for 9s, we have 1 for our set of 20 scores. And then finally, we have 3 individuals who got a perfect 10 out of 10. So the frequency with which 10 out of 10 occurred, we listed there as 3. All right, so one nice way to kind of check to see if you constructed your frequency table correctly is to take the total of the frequencies. So does anybody know what the total of these frequencies should add up to? It should add up to 20. So we started with 20 scores before we organized them to this table. And if we've done it correctly, we should end up with 20 scores after we organize this table. All right, so that is a frequency table. And notice that now the questions that I was asking before are a lot easier to handle. So the questions that I was asking before, things like how many subjects scored 8 or above, right? How many of my students scored 8 out of 10 or better on this quiz? Well, I can go to a score of 8 and see that 3 people scored an 8. And then I can go to a score of 9 and see that 1 person scored a 9. And then I can go to a score of 10 and see that 3 people scored a 10. And that equals 7. So 7 out of 20 students, they scored 8 or higher. Students that scored 5 or less need to come to a tutoring session. How many students am I expecting in that tutoring session? Well, nobody scored a 0, nobody scored a 1, but 2 students scored a 2, 2 scored a 3, 2 scored a 4, and 2 scored a 5. So 2 plus 2 plus 2 plus 2 sums to 8. So I can expect 8 students to come to that tutorial, or 8 students should come to that tutorial. So this makes it a lot easier when you're dealing with a frequency table to answer questions about your data, about your scores, hence the descriptive statistics strategy. Now, remember that I said to remember that this is possible scores. The reason that I mentioned that is because in this course and in your upcoming exam, one of the things you'll be dealing with is these frequency tables. So you'll be working with frequency tables and answering questions like the ones that I just mentioned. You know, how many students scored above this? How many students scored below this? Questions like that. But one question that always comes up, and this is your warning. One question that always comes up is the sum of the scores, right? So summing the scores, remember that summation notation, has been done over and over. It's done all the time in statistics. And oftentimes you're given a table and you're asked, what is the sum of the scores? What does that equal? If you have been reading this as the sum of X, not the sum of the scores, and you've been reading this table as just X, you will make the mistake that many students have made before, where you'll be looking, you'll be doing your exam, and you'll be like, sum of X, sum of X. Well, I got to look for an X. Oh, hey, look, there's an X. 10, 9, 8, 7, 6, 5. So I'll sum those up. 10 plus 9 plus 8 plus 7 plus wrong. That's not what it's asking for. It's asking not for the sum of the possible scores. It's actually asking for the sum of the actual scores. So what you would need to do if you had this table is you would have to say, all right, this is the sum of the scores. This is the possible scores. So I'm not going to fall for that trap. So I know I got to go to this frequency, and I got 3 10s. So it's going to be 10 plus 10 plus 10. That takes care of the tens. I know that I got 1 9. I read it off this table. Plus 9. I know that I got 3 8s. So that's 8 plus 8 plus 8, and so on and so forth. So again, that's going to become a lot more easy. You're not you're going to be much less likely to fall for that trap if you always read this as the sum of the scores. And when you're dealing with a frequency table, read that as the possible scores. I really wish they had another notation for there, like something like pseudo X, or I don't know what it could be, but they don't. You're going to see this in this course and outside of this course. So please, in a frequency table, read it as the possible scores. All right, so that's a frequency table of those particular scores. You'll also see frequency tables that use percents instead of frequencies. So this is often used when the numbers are just gigantic and they're just hard to work with. And you're talking about frequencies in the thousands, and it's just the numbers are just, you know, too unwieldy. So what you do is you simplify it again. You use descriptive statistics, and you say, all right, percent is defined as the frequency divided by the number of scores multiplied by 100. So your typical definition of percent. So in this frequency table, if we were to calculate the percent of students that scored a 10, we would have a frequency of 3 divided by the total number of scores, which is 20, multiplied by 10 by 100, and we can see that 15% of our students scored 10 out of 10 on this quiz. We can do that for every single score here, and we end up with these particular percentages. 20% of students scored 7, 10% of the students scored 5. And again, it's very easy to answer those questions, such as 40% of the students scored 5 or lower, 35% of the students scored 8 or higher. It makes those calculations a lot easier. And I don't have it up here, but if you've done the percentages correct, they should add up to 100%. Or very nearly 100%. Sometimes when you do it in Excel, you'll get 99.999999998789999. That's fine. But if you're off by like more than 1%, something went wrong somewhere. So just bear that in mind when you're working with frequency tables. All right, so that's the frequency table. Any questions on that so far? All right, one last time, because this question will be on your exam, and I don't mind doing that spoiler alert because it will be everywhere in stats. You are going to have to read a frequency table, answer questions about the distribution, about the scores, and this will be on there. The summation of the scores is something you'll see over and over and over again. So you will be asked to sum the scores given a frequency table. Remember this moment. All right, please do not just look for the first thing that looks like the scores and add up that column, go 10 plus 9 plus 8 plus 7. Remember possible scores. This one's the sum of the actual scores. So you got to go to the frequencies and unpack this frequency table. All right, so that's a frequency table. And frequency tables have their pros. They're very easy to work with mathematically. The numbers are there. They're very easy to just copy and paste into Excel. So they're easy to work with in terms of manipulating the numbers. However, sometimes you don't want to manipulate numbers. Sometimes you just kind of want to give an impression of the frequency distribution, a very quick understanding of the frequency distribution. And in that case, graphs are superior to the tables because visually they convey information very, very quickly. So when I typically report my results, if I have to report a distribution, I will use a graph to report that rather than a table, because looking at this graph right here, it's very, very easy to quickly see that most people scored either a 60 or an 80. Nobody scored below a 50. One person got 90 to 100. Just visually, you can unpack that kind of information a whole lot quicker. So in our frequency distribution graph, we'll take the exact same data that we have here, and we can take that and we can construct what's known as a histogram. And a histogram is just a fancy name for a frequency distribution graph. So this data in graph form is right there. So once again, this is the exact same data that we had for that frequency distribution table. And again, when you're reading this, think of it as an apartment building where different people are living on different floors. So from this frequency distribution graph of the possible scores and the frequency here on the y-axis, we see that nobody is living in apartment 0, nobody is living in apartment 1, but we got 2 occupants, 2 floors in apartment 2, 2 floors for 3, we got 2 scores for a 4 out of 10, 2 scores for a 5 out of 10, and again, different things can be assessed with a frequency distribution graph more easily than a frequency distribution table. So for example, right here, I can see that there are basically 2 groups of students in this course, right? We got one group of students over here, which are really struggling, and then we got another group of students over here that are doing rather well, right? So it's either or, you're either doing well or you're not doing well. I can see also that 7 out of 10 was the most common score. So it's easier to work with some things in a histogram, but easier to work with other things in a frequency distribution table. You will also have to know how to work and read histograms. So on the exams, you won't be constructing either a histogram or a frequency distribution table, but you will be reading a histogram or frequency distribution table. So again, know if I ask you how many people scored 8 out of 10 or better, you'll have to go here and be like, all right, what do we got for 8? 4 plus 1, 5 plus, is it 4? It's so hard to tell on this angle. It's easier here. We got 3, we got 3 plus 1 plus 3. So we got 7 out of 20, getting 8 or better. So know how to work with that frequency distribution graph. Basically, you read it, you unpack it, you recover the raw scores, and that's how you do it. And again, if you see the sum of the scores, don't fall for the fact that score is written right there. Again, that's just a convention. I wish it wasn't. Those are the possible scores. People could have scored a 0, but they didn't. People could have scored a 6, one did. Know that you need to unpack that and say, all right, we got 2 people scoring a 2, so that's 2 plus 2, plus 3 plus 3, plus 4 plus 4, all the way through. All right, so you can construct a histogram. Any questions on reading that graph? All right, you can construct a histogram. Your textbook also mentions a bar graph for these frequency distribution graphs. We're not going to nitpick on the difference between those two, but I will just mention it here just so that you're not confused. So a bar graph is used when your scores are not continuous and cannot be continuous. So in this quiz that I just kind of showed you, if it's impossible to score a 2.5, if it's impossible to score a 3.5, if you can only score whole numbers, 6 out of 10, 7 out of 10, then technically it should be a bar graph. And these gaps between these bars are your visual indication that you can't score in between. So most variables that we're interested in will either be continuous or pretty much continuous. So for example, height is a continuous variable. Depression is a continuous variable. You can have a height of 5'11". You can be 5'11 and a half, 5'11 and 3/4, 5'11 and 7/16, 7/8 or whatever it is. You can go those small gradations, but it's nothing that it's not gonna come up in this course. It won't be on the exam. Won't be in inferential statistics. But just so you know, that's the kind of convention that they have. All right, so any questions on the frequency distribution graphs, frequency distribution tables, or the idea of a frequency distribution? All right, so just one last thing before we wrap up the lecture portion of today. Frequency distributions are going to be used very, very often, and later on, as we get into inferential statistics, we're going to be dealing with frequency distributions and using them to do other things. So you really want to start developing your skills so that when you look at a frequency distribution, you don't really have to think about what it is that you're looking at. It's just kind of automatic, because later on we're going to be using frequency distributions to do other things, and you want to have your mind free to handle those other things. So hopefully, as you work with these, as you do your homework, as you do your post-test, as you do the quiz me portions on the study plan, you'll get to the point where when you look at this, you don't even have to think of the bottom and what it means. You know, oh, boom, possible scores. Y-axis, absolutely, frequency. And you just look at this and you can almost see the people living in the apartment building, and you just know, oh yeah, 2 people there, 2 people there. So hopefully you can get it to that point, because again, that when you get it automatic will allow your brain to use its processing power to do the extra steps that we're going to hit when we do inferential statistics. All right, other than that, that is all that I wanted to cover, all the new stuff that I wanted to cover for today. So just a reminder, if you got your feedback for your first pretest, so check it. If you did not receive 100%, then you can improve your grade up to 100% by doing the MyStatLab study plan. Now, the study plan does use a customized suggestion algorithm, so it'll take a look at how you did on the pretest, it'll take a look at how you did on the homework, and it'll suggest things for you that you might need to work on. However, if you want to earn the 100% of the points towards your pretest, use the quiz me option and complete the whole study, the study lab options. Not just the ones that it suggests, but the complete list for those 100%. I would also recommend, even if you did get 100% on the pretest, it is just one more chance to run through these concepts, one more chance to do a little wax on and wax off. So I would highly recommend it as well. But just know that if you are using it to bump up your grade on the pretest, make sure that you complete the entire quiz me options. I'll also want to mention that pretest 2 on the chapter 2 pretest, so the next chapter, that is due Wednesday, August 29th at basically at midnight. And as well, homework assignment number 2 on chapter 1, that is due, oh, it's double due. That is due on Wednesday, August 29th at 11:59, basically at midnight as well. We are not meeting on August 30th, just one more time to remind you of all that. The class will be available online. However, we have to keep up to date. We want to make sure that we're on the pace, that we're ready to go for chapter 2. So the pretest and the homework are still due as usual. And just one more time, know your due dates. Make sure that you're keeping up. It's in the syllabus. It's in the MyLab statistics plan. Don't miss a pretest. Don't miss a post-test. Don't lose points on your homework because of a due date. There's plenty of time to get these assignments completed. So make sure that you maximize your score, because you're going to be doing the work anyway. Let's get the full points. All right, other than that, that is all that I wanted to cover for today. So if you've had a particularly difficult day today and you're kind of all statsed out, feel free to call it an early day. However, this would be a great time to engage in a little bit of practice. So suggestions would be, look over your chapter 1 pretest. If you got things wrong and you don't understand what's going on, you can call me over. If you want to start your homework and give that a go, feel free as well. Remember, you have those multiple attempts for both your pretest, post-test, and your homework. Also, if you struggled at all with the order of operations homework, or maybe you didn't, not homework, order of operations practice Excel sheets, or maybe you didn't get a chance to give those a go right now. Make sure that you got that down. A lot of things to try. If you struggle with anything, call me over. and we'll make sure that everybody is off to a blazing start on stats. But other than that, that's the new thing that we wanted to cover. So again, if you're tapping out, feel free, and I'll see you here again in a week. All right, but again, try your practice. If you have questions, call me over. There we go.